During week 3, the embryo is a flat disc made up of 3 germ layers: the endoderm, the mesoderm, and the ectoderm. From the endoderm, which you can think of as being the belly side of this 3-layered embryo pancake, a fluid-filled bubble called the yolk sac forms and grows alongside the developing embryo. The digestive system starts forming when the embryo folds along its vertical and horizontal axes, so it rolls up on itself and turns into a tubular organism that looks kinda like a little shrimp. Folding also pinches the yolk sac, kinda like squeezing a balloon through a ring, so a part of it goes inside the embryo and forms the primitive gut tube. The primitive gut tube is initially sealed off at both ends. The buccopharyngeal membrane at the top separates it from the primitive mouth, and the cloacal membrane at the bottom separates it from the primitive anus. This tube is divided into 3 parts, based on the arterial blood supply. The first portion is the foregut, and it's nourished by the celiac artery. The middle portion, the midgut, is nourished by the superior mesenteric artery. For a little while, the midgut communicates with the yolk sac mothership through the vitelline duct, which is eventually incorporated into the umbilical cord. Finally, there's the last portion, the hindgut, which is nourished by the inferior mesenteric artery. The hindgut ends with the cloaca, which is a primitive common drainage site for the urinary, genital, and digestive systems. Now, the foregut gives rise to the superior part of the digestive tube, up to and including the first half of the duodenum, as well as the liver, the gallbladder, and the pancreas. At the very top of the foregut, starting with the buccopharyngeal membrane, there's the primitive pharynx, which is initially just 5 sets of symmetrical pharyngeal arches. These pharyngeal arches turn into various bones, muscles, and cartilages of the head and neck, and the last 2 arches give rise to the pharynx. Below the pharynx, the foregut gives rise to the esophagus. In this region, there's an outpouching of endoderm called the lung bud, and it sprouts from the anterior wall of the foregut. During week 4, a tracheoesophageal septum forms a barrier that separates the lung bud from the foregut. The anterior compartment develops into the trachea and lungs, and the posterior compartment develops into the esophagus. The esophageal epithelium and glands derive from the foregut endoderm, whereas the esophageal muscles derive from the surrounding mesoderm. The epithelium proliferates and initially fills up the lumen of the esophagus, turning it into a solid rod of tissue. But by week 8, a process called recanalization happens and the esophagus turns into the hollow tube we know and love. Under the esophagus, there's the primitive stomach, which starts out as a small dilation of the foregut. The stomach has a dorsal or posterior border and a ventral or anterior border. The dorsal border is anchored to the posterior body wall by a 2-layered sheet of mesoderm tissue called the dorsal mesogastrium. And the ventral border is anchored to the anterior body wall by another 2-layered sheet, the ventral mesogastrium. Starting with week 5, the liver grows between the layers of the ventral mesogastrium, and the spleen between the layers of the dorsal mesogastrium. The dorsal border of the stomach grows a lot faster and forms the greater curvature of the stomach, while the ventral border becomes the lesser curvature. Alright, so if we switch to a top-down view of this developing stomach, we see that as it grows, it undergoes a 90-degree clockwise rotation along its length, pulling the dorsal and ventral mesogastrium with it. This moves the greater curvature to the left side of the body, and the lesser curvature to the right side. And now the stomach has an anterior and posterior face. As the stomach rotates, the ventral mesogastrium becomes the lesser omentum. The dorsal mesogastrium grows longer and bends as the stomach rotates, forming a peritoneal cavity derivative called the omental bursa, between the stomach and the posterior body wall. The omental bursa communicates with the great peritoneal cavity through a small opening known as the omental foramen. The omental bursa grows and fills with peritoneal fluid, developing 2 projections, the upper recess that extends behind the developing liver, and the lower recess that extends downward over the developing intestines. Eventually, the sheets of dorsal mesogastrium that form the lower recess fuse and form the greater omentum. Finally, the stomach rotates once more, but this time in a frontal plane, So imagine now looking at it from the front. This final rotation repositions the superior end of the stomach to the left and a little bit lower, and this will become the cardiac sphincter, while the inferior end moves to the right and gets a little higher, and this one's called the pylorus. Below the stomach, there's the developing duodenum. The first two sections of the duodenum derive from the last part of the foregut. The rotation of the stomach turns the duodenum into a C-shaped loop, with the middle of the C on the right side. The last portion of the foregut also has tiny tissue buds, which grow pretty large and develop into the liver, the gallbladder, and the pancreas. The liver bud, also known as the hepatic diverticulum, gives rise to the liver, the gallbladder, and the biliary duct system. This bud forms inside the ventral mesogastrium and extends into the septum transversum, which is a sheet of mesoderm that separates the developing heart from the midgut. The liver bud separates in two parts, a larger superior portion that becomes the liver, and a smaller inferior part that becomes the gallbladder. Hepatocytes of the liver are derived from endoderm of the foregut, and they start producing bile during the 12th week. Kupffer cells, on the other hand, are derived from the mesoderm, and are special macrophage cells that play a role in local immune defense. Hematopoietic tissue is also from mesoderm, and starts forming red blood cells during week 6. So the liver functions as a major hematopoietic organ up until the last month of pregnancy, at which point the bone marrow takes over. Now, with the pancreas, there are actually two pancreatic buds, a ventral bud and a dorsal bud. And the two eventually unite to give rise to a single organ. The dorsal bud appears first, and forms the body, the tail, and most of the pancreatic head. The smaller ventral bud unites with the dorsal bud when the duodenum rotates, and it gives rise to the rest of the pancreatic head. The pancreas starts secreting insulin during week 10. Now, the midgut gives rise to the third and fourth sections of the duodenum, the jejunum, and the ileum, which are all parts of the small intestine, as well as the cecum, appendix, ascending colon, and the proximal 2/3 of the transverse colon, which are all parts of the large intestine. Now, taking a more three-dimensional view of the midgut, it lengthens a lot over a short period of time, and the embryo's abdominal cavity becomes too small to hold it all in. So what happens is that the primary intestinal loop, which is the first loop of the intestines, herniates through the vitelline duct and develops inside the umbilical cord. This is called physiologic gut herniation, and it lasts until about week 10. The primary intestinal loop protrudes into the umbilical cord like a bobby pin, with the superior mesenteric artery growing between the two limbs of the loop. The cranial limb of the primary intestinal loop initially develops above the superior mesenteric artery, and the caudal limb of the primary intestinal loop develops below the superior mesenteric artery. First off, though, the loop rotates 90 degrees counterclockwise, around the axis of the superior mesenteric artery, and moves the cranial limb to the right side of the artery, and the inferior limb to the left, kind of like a key inside a lock that's turned counterclockwise. That cranial limb gets really convoluted, marking the future jejunal and ileal portions. Whereas the caudal limb develops a small dilation that eventually develops into the cecum and appendix. In week 10, when the abdominal cavity is big enough for the loop to go back inside the body, the loop rotates a final 180 degrees and moves into the abdominal cavity. Now, what used to be the caudal limb ends up framing the developing small intestine loops, above and to the right, and this gives rise to the ascending colon and the proximal 2/3 of the transverse colon. Finally, you've got the hindgut, which includes the distal 1/3 of the transverse colon, the descending colon, the sigmoid colon, and the upper part of the anal canal. And this starts after the caudal limb of the midgut and extends to the cloacal membrane. The lower portion of the anal canal derives from the primitive anus, or proctodeum, which is a pit of ectoderm that forms just below the cloacal membrane. Also, during week 4, the urorectal septum forms, and it separates the cloaca into an anterior urogenital sinus and a posterior anal canal, which are covered by the urogenital membrane and the anal membrane, respectively. At the end of week 7, the separation is complete, and the anal membrane ruptures, so that the anal canal is now continuous and opens in the tail region of the embryo. Alright, as a quick recap, the digestive tract and associated organs develop from the primitive gut tube. Because the abdominal cavity doesn't grow as fast as the developing organs, the intestinal loops protrude into the umbilical cord during week 6, but then they go back into the body by week 10. Initially, the tube is sealed off by the buccopharyngeal membrane superiorly and the cloacal membrane inferiorly. But the membranes disappear and continuity is established in the gut tube, between the mouth at the top and the anus at the bottom.